you stare at the sky at night, the universe does not seem finite. Rather, it seems to go on and on, to infinity and even well beyond. Giordano Bruno loved this thought. Finite was one thing his God was not. And today most of us would agree with this once deeply heretic idea. But some mathematicians, including me, are not so at ease with infinity, because that's one thing we cannot see, something that just might not be. Instead, we have found some ground for a finite universe without a bound. It was the great Henri Poincaré who first came up with the idea. To circumvent any paradox, Poincaré first looked at the clock. The hand keeps moving clockwise, and there's no end at sight, yet the clock is clearly finite, and noticing this was a blessing in disguise. Poincaré had discovered a marvel, namely the topology of the circle, a shape that has no boundary, and yet does not go to infinity. But his genius was to go further by looking at shapes that are bigger. Circles have only one dimension. What could be their generalization? Where our Earth is a sphere, which is known to have no frontier. Fly straight to the north, and your trajectory will repeat thenceforth. But the sphere isn't the only thing to be at once familiar and surprising. As we discussed it previously, Pac-Man's world has a similar property. His world is a sort of donut, which mathematicians call a torus. Equivalently, we can see it as a square whose opposite sides are identified, so that when Pac-Man's living through the right, he should appear on the opposite side. So here we have two kinds of surface, which are both finite and boundless shape. But the two shapes aren't the same, and that's one thing we're going to have to tame. One thing to notice about the sphere is that its loops can be made to disappear. And this transformation, importantly, can be achieved continuously. But that's not the case for the torus, whose loops may be surprising to us. Look at this loop, for instance. It will always have to travel the left-right distance. You can't make it disappear continuously. Thus, the torus is not simply connected. Now, we've already seen another example, namely the topology of the circle. The loop that goes all around can never ever be pinned down. Thus, as you might have suspected, like the torus, the circle is not simply connected. Now, I guess that was worth our attention, but a real space has 3 dimensions. So could we generalize these to something that apply to our actual surrounding? It was at the turn of the century that Poincaré envisioned a finite universe without boundary. He even discovered different topologies that our 3D space could potentially be. In this video, I'll only focus on generalizations of the sphere and the torus. And I will start with the latter, since I believe it to be simpler. The 3D torus is basically a cube, whose faces you can walk through. And when you walk out through the right, you reappear on the other side. If you walk through the face up there, you reappear through the down square. And finally, we have the same sort of facts, with the direction front and back. Once again, as you can guess, the 3D torus is both finite and boundless. But as you may have suspected, the 3D torus is not simply connected. But what about the 3D sphere? Well, let's now describe it here. First, recall that our planet Earth has been a 2D sphere since its birth. But our Earth can be represented by maps, and while in many respects these are traps, they do often provide great insights into a shape that's both boundless and finite. For instance, by being centered on the North Pole, a disc-shaped map can represent Earth as a whole. Our 2D sphere is depicted by a map that is a 2D full disk. But careful and please pay attention, the edge represents a single location. Namely, the boundary is the South Pole. Remember, the 2D sphere has no real edge at all. Likewise, the 3D sphere is a 3D full ball, kind of like the interior of an apple. But once again, there's no boundary at all. The skin is a single point, that's the South Pole. In particular, all points close to this fourth border are actually very close to one another. So, when you fly out through the skin, from anywhere else on the skin, you then get in. And finally, one thing that can be concluded is that the 3D sphere is simply connected. So we have two examples here of 3D finite spaces without boundary. Namely, there are the torus and the sphere, but what else could there be? That's a question that Poincaré asked, but he wasn't feeling up to the task. So he asked a simpler question, and he answered it in the case of 2 dimensions. He proved that the 3D sphere was the only simply connected surface, but he couldn't prove that the 3D sphere was the only simply connected 3D space. At the end of the 5th supplement of his seminal memoir, Poincaré boldly claimed that this question would take him too far. This question is now known as the Poincare Conjecture, and indeed it would take over a century for other mathematicians to provide an answer. At last, in 2003, it was the Russian Grigory Perelman who figured it all out. His proof was both tricky and lengthy, and all mathematicians had plenty of doubts. But in the end it got accepted. Only the 3D sphere is simply connected. For his proof, Perelman got a lot of awards, including a prize of $1 million. But he hated being in the news, so everything he was offered he refused. Today, Perelman seems to have disappeared, and everyone agrees to say that he was a bit weird. But undoubtedly, his achievements were very spectacular. Not only did he prove the infamous Poincare Conjecture, but he also proved that he was simply today's greatest geometer. Hey, so I hope you've enjoyed this last episode of our series on the theory of general relativity, this poetic episode. Next time we're going to start a new series of videos on logic and the foundations of mathematics, and I hope to convince you that logic is anything but just logic, and truth is far from being a simple concept. I hope you join me for that. If you've enjoyed this episode, please comment it, share it, show it to your friends, subscribe to the channel, and I hope I'll see you next time.